this is the structure. Right? There is a cylinder and fins, longitudinal fins are attached. Where do you see this? It resembles a typical electric motor that you see. Right? More or less the same. Now this is the base surface. And these are the fins. How many fins are there? 1, 2, 3, 4, 5, 6, 7, 8 fins. 8 longitudinal fins. Now you tell me, without fins, the heat transfer from this is simply by convection. This diameter, if you take d, pi d is the perimeter into L, right? Total length of the cylinder, length or height. So that is the surface area of the cylinder, which is exposed to surrounding fluid. So therefore, HA, where A is this pi d into length of the cylinder, that is the surface area, into temperature of the surface minus temperature of the surface. That would have been the heat transfer. Now, since fins are attached, the heat transfer rate would become, see, whatever the area that was available earlier is now cut down. How much? See, this area is occupied by this part, right? This part. The 8 small parts are cut down. So therefore, the heat transfer from the remaining surface is as it is, that is available. So from the base surface, see the gaps between the fins, that belongs to the cylinder. So that area, the heat transfer proportional to that area. Now in HA delta T, what do you write? Area is now not the entire area. You have to minus or subtract this. Plus heat transfer rate by each of these fins. Multiplied with N. N is the number of fins. Right? So what's the procedure? You find out heat transfer from the fin, just like we did earlier, Q fin. Then from all the fins that are attached to it, N into heat transfer rate from each fin. Plus the heat transfer rate from the remainder of the cylinder surface, which is not covered by the fin. Right? So that is the physical description. Now see what is the given data here. What is the length of the cylinder here? Sorry, length of the fin. See, this length, width, breadth, height, depth, don't go by one single standard rotation. I told you, right? See, if I am standing here, I say this is height. Suppose it is tilted 90 degrees, I can't call it as. It become another dimension. So length I can take this, right? So generally standard convention is length is more than width. That's a standard convention. Otherwise L, W and H are random. Right? That's the first one. Now, length of the cylinder is, you measure it along the axis. But length of the fin is different, right? So what is the length of fin? This is not assumed to be length of the fin. Now the fin is starting from here. This is the base. And extending perpendicular to it. Right? Or let's take this fin, right? From here to here. So that is the length of the fin. But in the problem, what is given? You see here, the height of 0.6 mm thick. Now what is the thickness? This is the thickness. Right? Now, what is L from this problem? No, height of the fin is with reference to its position on the cylinder is talking about. Right? Now, as per our nomenclature, for the fin, this dimension is taken as L. Are you all following? Right. So L is gone, D is gone. Next, what about the other dimension? From the distance from this point to this point. Obviously, it must be the other dimension, third dimension. L is over, T is over, it must be done. But these are all L, W, T are with reference to the fin. If I talk of taking the, all these ones taking the reference of cylinder, we call it as length of the cylinder, right? So don't go by that. Okay. So therefore, Now the dimensions how should you take? L is 1.27 centimeters. T is 0.76 mm. Now what is W? Can anybody tell? 1 meter. Because W is equal to length of the cylinder. Width of the fin is same as length of the cylinder. So now once you understand it, problem is quite routine as you be done. So take down till this part and you just find the heat transfer rate from one fin. Rest I will continue. Please go ahead. All of you. Your attention please. So now which case shall we consider? Case 3. Right? So considering case 3, what is Q fin that you have got? 45. Please listen. Q fin is equal to 45.74. So majority of you got this value. I am assuming it is correct. Right? Those who differ with this maybe you can cross check with your friends. Right? Now that is one part. Right? How many such fins are there? Right? And otherwise, Q of cylinder is equal, please listen here, Q of the base surface, base of the fin, that is the cylinder, plus Q of fin, each fin, multiplied by number of fins. Now how do you find from the base surface? H into area of the base into its surface temperature Ts minus T infinity. This is the heat transfer from the base surface. Plus Q fin into, now let's see. This is the diameter, right? Now what is the area of the base surface? H into area of the base surface is, perimeter is pi d minus this thickness you should remove. Thickness of one fin is d and n fins is n into d. So now what is the perimeter? Pi d, sorry, capital D antunnam. Pi d minus n into d. This is the perimeter multiplied by length of the cylinder. So length of the cylinder, because we assumed it as W, I can write, or if I write length of the cylinder, whatever. When you write in the beginning somewhere W, you can mention this as width of the fin, which is equal to length of the cylinder. So that my meaning is not width of fin. Fin sambandham ledhu. Cylinder is my reference point. So this W should carry that meaning. Right there itself, wherever you wrote W is equal to length of the cylinder. Okay. So this is the bare surface area AB, right? This is into Ts minus T infinity plus Q fin into N, where N is number of fins is equal to how many? 10. Now you have got every value in this equation. Simply substitute and find the value. You have the right explanation wherever you want to the side where AB is area of the base surface of the cylinder. So we write the description of AB as area of the base surface of the cylinder that is available for convection heat transfer. That is the definition, which is equal to perimeter available for that means we are cutting down the fins. Perimeter available into length of the cylinder, not length of the fin. So this is perimeter into length. This will give you the surface area, which is equal to pi d minus nt. That is the perimeter available. This is the total perimeter minus this we are calling perimeter available into length of the cylinder is double. 724.2. I guess the units are watts. Please listen. Temperature at the end of the film, right? That means at the tip. These all the things are under similar conditions. So everything you do, that you have to do all the things. So how do you find this temperature distribution equation for case 3? T minus T infinity is equal, sorry, by Tb minus T infinity is equal cos h of m into L minus x if it is end insulated, otherwise it becomes Lc minus x divided by cos h m Lc. Here temperature is to be found. Temperature at x is equal to what? What is the value of x? L. At x is equal to L. So on the right hand side, what do you get? Cos h m Lc minus L divided by cos h m Lc. Substitute and find the value.
146.78. 146.78.
146.738 degrees Celsius.